for last year. Is it recording? Yes, it's recording. No, thank you for that point. So let's continue, guys. So this still helps us to get assignment 3. And as I said, in mathematics, it's important that you know the basics. Just you knowing to solve a problem doesn't necessarily mean that you'll be able to answer a different question when you get it. But knowing your basics, meaning that if you are given any question regarding exponential and logarithmic functions, then you can be able to answer. So today we're looking at exponential and logarithmic equations. That's part of our assignment 3, isn't it? So now the exponential equations, logarithmic equations, and compound interest. So those are the objectives of this particular section. So let's look at exponential equations. Can you see the screen, guys? Yes or no? Can you see the screen?
Yes.
Thank you.
Yes, ma'am, we can.
Yes, ma'am.
Danko. So exponential equation is one in which the variable occurs in the exponents. Remember, in mathematics, we say an equation is something that you have what equals to what, right? So we then initially we had x squared plus 2x plus 3 maybe is equals to 0. We then say this is an equation, or y is equals to x squared plus 2x plus 3, right? We then call that an equation. Now, you notice that here the variables were always it's either the bases with powers. Now they're saying, okay, fine. We don't have x squared, but instead we have what? Maybe 2 to the power of x, where x is the power now. That's why they're saying an exponential equation is one in which the variable occurs in the exponent. Some exponential equation can be solved using the fact that exponential functions are one-to-one. What do they mean by that? They say that same thing that we talked about last week. They're saying that some exponential equations can be solved using the fact that the exponential functions are one-to-one. We know that exponential function, if it's a one-to-one, then it has an inverse, right? So if the function has an inverse, meaning that it follows the inverse function property, meaning that if you take a function, take a composition of a function and its inverse, then it gives you what? It gives you x, or you take a the inverse and put the function itself inside, then it will give you what? It will give you x. So they are saying that because of those functions are one-to-one, therefore we can use this property to solve. This means that this implies x is equals to y. Are we all together there?
Yes.
All righty. Now let's look at exponential equation. Why am I going down? Sorry. The following guideline describes the process for solving exponential equation. Let's listen to the guidelines. Guidelines for solving exponential equations. Isolate the exponential expression on one side of the equation. Take the logarithm of each side, then use the laws of logarithm to bring down the exponents, then solve the variable. Are those rules in the mind?
Yes, ma'am.
Yes, ma'am.
So let's go. Now they say that consider the exponential equation this. Find the exact solution of the equation expressed in terms of logarithms. Now this is how I'm going to ask you in the exam. Not number B, where I say use a calculator to find an approximation to the solution rounded to 6 decimal places, because we're not using a calculator, right? So this is not what will be asked in the exam because of a calculator. So what was step number 1 for solving this? So we have 3 to the power of 2x plus 2. Where am I now? Come back. X plus 2 is equals to 7. What was the first question, guys? What was the first guide?
Isolate the exponential expression.
Thank you. So if you isolate the exponential, do we have to isolate it again? Or is already isolated? Okay, because it's already isolated, we can see the constant, anything that does not have an exponent of the variable x, y, z, or any variable alphabet. It's already on the right-hand side. And then on the left-hand side, we have 3 to the power of x plus 2, which is the exponential, the exponential expression that they are saying we should isolate. Isolate meaning that take one to the other side and separate them, basically. Now, then it says take the logarithm of each side, then use the laws of logarithm to bring down the exponent. So which log are we using? Do we use len?
No.
What are
Learn.
we using?
We use learn, ma'am.
You use len.
Yes. Even
Why
Lynn
are
is
you
gonna
using
be fine
len? Why are we using len?
because in terms of Lynn,
Why are we using len? If you're going to say why are we using len? People are saying len. Say yes, yes. And is there someone who's saying no, we're not going to use len?
I was saying no, but now I'm not so sure. Because everybody else is saying Lynn.
You're not sure why you said no. What if your no is right? Remember, not just because everyone is saying len doesn't necessarily mean they are correct.
Mm.
Aren't you supposed to use anyone as long as they have the same basis?
Guys, someone said something there.
Mm.
They are saying that aren't you supposed to use anyone as long as they have the same basis? Please
Yes,
help.
ma'am.
Why are you saying that, guys? Why are you saying that?
Ma'am, because I think if you have the same basis, then you can bring down the exponents.
If you have the same basis, you can do what?
You can bring down the exponents.
Are we agreeing with that? Let's go back to our financial maths in grade 12. Which log did we use?
The normal log.
Can you remind me the normal log?
LOG.
LOG. What do we call the normal log? What do we call the normal log, guys?
Let me try to assist her. Like, back then during our high school days, we used to use log a to the power of b, which explains that it tells us that a to the power of what is b, something like that. For example, you can say log base 2 to power of a. Yeah.
So if you're saying we're using the normal log, why are people saying no, we're not using the normal log, we are using what's this? Len. Those who are saying len, fight for your answer. Guys, those who are saying len,
We
fight
can
for
use both.
my issue is the both parts. I have an issue with both parts. I really have an issue with both parts. We can't use both.
Ma'am, I don't think we can use Lynn because we talking about exponential functions. or is exponential equation. I don't know.
And when we're talking about exponential function, what is the inverse of an exponential function?
It's a logarithmic function.
There we go. It's a logarithmic function. And our laws of log last week, they were given in what? In a log. Now, because we know that the exponential, the inverse of this is log. So we can't use the, what's this? We can't use the ln, because we know that this is an exponential function.
And
If we had e to the power of x somewhere, then we can use ln.
so, ma'am, we use log because it has to transform the number into a new value that is related to the number of times where it base needs to be multiplied to itself to equal to the original number.
Not really that, but because of the one-to-one property. Remember, they said by using the fact that exponential functions are one-to-one. That's what they are saying.
Hmm.
By using the fact that exponential functions are one-to-one. So since then the exponential functions are one-to-one, this property applies. And once this property applies, it means that you need to check what's the inverse of that function.
Okay.
Do you see that? Now, because we have an exponent, what's the inverse of an exponent? It's not ln, but it's what? It's log.
It's log.
That's why in your grade 12 financial mathematics, when you're told to find, I think, t or I, right? You then went and took the log both side. Like this. Because of this one-to-one property. Here. Do you see that?
Yes.
So now, sorry. Because of that one-to-one property, that's why you're saying, I can't use, because I know the only time my inverse of an exponential, well, I know my inverse of, not, is it inverse? Hey, what am I saying? Yes, the inverse today, because I know that my inverse of this function is a ln function. So meaning that if I see a ln here, e to the power of x, then I have to use ln. Do you see why when I use ln, guys? Because majority said ln.
We use ln because there's an e to the
There's
power
an
n.
e. Yes,
Okay.
because we know that the inverse of e is what? Is ln.
Ln.
And we know that if there was a ln here, let's say I give you an equation with a ln, then you have to go and use an e to cancel out. Because
Yes.
of the inverse property. This. Because why? One to one.
So this one requires us to use log, not ln.
Yeah, not ln. Not ln. Because of that inverse property, that's why we are able to do that. Do you see that? So now, and the other thing, the reason why we can't do easy, because we can't change 7 to the power of 3. The reason why we are even using log in this case, because someone say, but then I can say, for example, let's say I have 2 to the power of x plus 2. Alrighty? Are we all together?
Yes.
Okay, let's start
Yeah.
here. So we have 2 to the power of x plus 2 is equals to 4. In our grade 11, 10, 11, 12, what would we do there?
You can say maybe 2 to the exponent 2.
Yes. So we used to say 2 to the power of x plus 2 is equals to 2 to the power of 4 to the power of 2. Then we know bases are the same. We then do what? We then say x plus 2 is equals to 2.
Yes.
Do you see that? That's what we used to do, isn't it?
Yes.
Then we say x is equals to 2 minus 2, where x is equals to 0.
Yes.
Are we all together there?
Yes.
So now, in mathematics, when they say that this applies for the same thing of everything, what they mean is if you are given a theorem and you can go and find one counterexample, just one, out of the entire thing, then the whole theorem or the whole, let me say hypothesis, because then theorem means you have proven. Then the whole, if you have an hypothesis and you can find one that says, no, this hypothesis is wrong, then the whole thing is wrong. So meaning that they are saying that if we, because of the one-to-one inverse function, it means that we could have applied this to this and get, let's see if we can get 0. Should we do that?
Yes.
So let's do that. So you then say, we said, okay, this is what? E to the power of x plus 2 is equals to 4, right?
Mhm.
And then we are saying we are not going to use ln. Why? We are going to use what? A log.
Log.
Reason why we are using log is because of the inverse property that says that if I take the composition of the inverse as well as the function, then I get x. Or the composition or the inverse, function then inverse first, then I get x. So composition, it just means, remember, it just means assignment 2. You take a function, you put it inside another function. So if I take log here, log of, okay, let me just erase here for now. So then if this is 2 to the power of x plus 2, which is equals to 4, right? Now let's say you didn't do grade 10 exponential functions. You just did pre-calculus where you're saying, I'm solving using logs. So then you go and say the log of 2 to the power of x plus 2 is equals to the log of 4. Are we all together there?
Mm.
Yes, ma'am.
Now, we know our log laws. We can write this as what? 2 to the power of 2. Are we together there?
Yes.
Mm.
So then, because of our exponential log says that we can take the power outside the log. So this becomes x plus 2 log of 2, which is equals to, we take this one, 2 log of 2 as well. Then we divide by log of 2, both sides. What you do on your left, you do on your right hand side, grade 3. So then this becomes x plus 2 is equals to 2. So then x is equals to 2 minus 2, where x is equals to 0. Do you see that?
Okay.
Yes, ma'am.
So meaning that because now the log generalizes now and say, not every time you can change what's in the right-hand side and make it a power such that it has the same base. That's what they're saying. That's why they're saying logs are very important when it comes to exponential function, especially because of the one-to-one relationship. Well, because one is an inverse of the other. So they are saying, okay, fine. Now I have this particular problem over here, where I have 3 to the power of x plus 2 is equals to 7. I cannot change 3 to the power of something to give me 7. So then I use log. So then I say log of 3x plus 2 is equals to log of 7. What you do on your left, you do on your right. So this is x plus 2 log of what? 3 equals to log of 7. Then we divide by log of 3 both sides. What you do on your left, you do on your right. So this is x plus 2 is equals to log of 7 over log of 3. Therefore, x is equals to log of 7 over log of 3 minus 2. In the exam, this is where you're going to end. That's the exact solution.
So
Ma'am,
at
can I
at
ask
the end of the
something?
day, we actually need to find x.
Yes, isn't that they say consider the equation? Remember when you're doing an equation, what have they ever said to an equation? They always say solve the equation, isn't it?
Yes,
Yes.
ma'am.
They don't say look at the equation, smell it and touch it. They say solve the equation, meaning that you solve for whatever is missing. Simultaneous equation. The reason why it's simultaneous because there are two, so you're solving the same time, two different variables.
Mm.
Okay.
Ma'am, can I ask something?
Hmm?
Can I ask a
Yeah.
question?
Yes.
So, there by your final answer,
Mm.
would I be wrong to make the 3, the base, and then write it log 7, then say -2.
3 the base how?
Like write log base 3, 7.
Log base 3, 7.
Yes.
I think let's go. We might have to go back to change of base. Let me go and look at the change of base. How does it work?
Okay.
You know why I'm saying that? Because last week we did change of base, and this is a common log, and we know a common log has base 3. Do you see that? So let's see if we go to change of base, and if that will work, then I'll come back and tell you. Or you can even try it on a calculator and see if it gives you the same answer. Now they say use a calculator to express to find an approximate solution. Why are they saying exact solution and approximate solution? What's the difference?
I think it's the fact that now we need to give answers to our equation that we already solved.
But why are they saying approximate? Yes, you're right. But why are they saying approximate and this is exact?
Approximate. Oh, isn't
It is.
So when they're
Because
saying yes, sorry, because
the number is irrational. So since the number is irrational, they want the 6 digits. Okay. So that's why they say irrational. I mean, approximate, because you're not
thank you.
going to get the exact number.
Thank you very much. This is the exact solution, meaning that if I put this one inside here, if I put x here, I'll get 7. But if I put a number, which I get in a calculator after solving this, let's say I got 3,456,7, right? I put in there, I'll get maybe 6,91, which is an approximation of the equation. Especially when it comes to irrational numbers, with irrational answers. Same in financial maths, we'll get irrational answers. Your calculator, I think it ends to 13 decimal places, if I'm not mistaken, or 8, right? Now, there are computers which goes over 20 decimal places, 100 decimal places. Now, whoever used more decimal places will get a better approximation to what? A better approximation to the solution. That's why in the exams, they'll tell all of you to round off to 2 decimal places because it's important. Someone can round off to 3, someone to 4, and whatsoever. That's why that's the difference between the approximation and the exact solution.
Mama just checked, it's the same answer.
Alrighty. So it means that's the change of base, which we need to take it and then redo it maybe for the next session next week. Yes. Thank you. So let's see if we are right, but we are always right. Oh, not always right, but yeah, most of the time, 99%. So you see, as it was said, it's an approximation. Do you see that? If you put that, you might not get exactly 7. You might get like 0, something, something. Yeah. Nazoge.
So in order for us to get that answer, we just substituted that equation we solved, and then we calculated.
Yes, you can go and try and put x. X we said is what? It's log of 7 over log of 3 minus 2 minus plus 2. If you do that, you'll go and check and see what happens. Yes. Please discuss. I need to drink water. You know what goes down must come down. Keep. Okay, I want you to. No. I want you to discuss the following. It has e to the power of x something. So I want you to discuss it. Let me
I think we can actually take -6 to the right hand side.
Yes. Wouldn't this be ln because it's the inverse because of e?
Yeah,
No,
it
I,
will,
I
but
think
I
I think
think
I think this E is more like X. If I'm not mistaken,
Yeah.
like
it's
I think we can add ln at the end. We must first solve this. I think, or maybe like, can we use K method before we start
Wait, what
introducing
is
the
this
ln?
exponential function? Like,
no. I
But
think
this
two
one,
bases are the
Baba.
same.
must take
You add the
this side.
exponents. Oh.
Guys, wait. We are wrong. This thing looks like a quadratic equation, and it actually needs to be solved as in like as a normal quadratic. I'm not sure if I'm seeing things, but
But how will you factorize this? You can't. That's why, hence I'm
oh,
saying
okay,
we
You
okay.
need
use
to
the power
first
rule. It
There's a
maybe
logs
way.
of
use K
exponents.
method first, then find the value of
And
K, then substitute back and use ln.
oh, when the two exponents are
Two
the
X is
same,
the
you add the
problem. 2x is the problem. Now I see.
what if
Yeah.
we just keep
Now
the
it's
6
kind of
into
clear.
the other side? We should have got e into
No,
x so plus 1.
don't you think?
Then and that.
Don't you think we need to minus the x exponent, so that we can be left with 1x on the e? Because you see, it's 2e that side, and it's 1e that side.
You can use laws of exponents, the power rule.
Maybe we can take the 6 to the right hand side and then deal with
Yeah,
the
you
2.
are right.
We cannot do that.
We
You
cannot do
cannot
that.
take the 6 to the other side. In order to isolate, I don't know, you use the laws of exponents, the power rule to you're gonna say ex and then open brackets to the power 2 minus you rewrite the rest of the equation, and that's when you factorize.
You factorize
Use
it,
the
and if you
quadratic, I mean, use the quadratic form. It will result in a quadratic what equation, and
Equation.
then
Or
you'll end up having two
we're
solutions.
gonna take the e to the exponent x outside, and then after that we deal with what? It doesn't make
I
sense.
don't understand this way.
let's think factorize
Hence
it,
How
then
I
we
about
can do two.
suggested the K method.
guys?
Huh?
Guys, how about you say let y is equals to e to the exponent x, and then we solve it. So whenever there is e, and then we say it's a y. So with this quadratic equation, you're gonna say
Guys,
like,
you are overthinking these.
But the problem is gonna be 2x. I've never seen it a
no,
quadratic
not
equation
2x.
with
We put a
x.
y. We put a y instead of x.
Huh? On
Wow.
the exponent.
But
How do you do
No,
that?
Instead of
you said let y is equals to ex. So wherever there's ex, you put y. What is that?
Oh,
wait, what about the x?
So it will be
I'm
y
confused.
a y to the
No,
power of
the
2 minus y
e to
minus
the
6
e.
equals 0.
You let y is equals to e to the exponent x.
Mm-hmm.
I come back. I come back. I come back.
I'm confused by the
Okay,
2x.
don't
The
be
2x is the
confused.
one that is the problem here.
Don't be confused. Do not be confused. Now, there's someone who said, "I man, this looks like a quadratic," and you are right. It is a quadratic.
yes.
Can we deal with that person first? Why are you saying it
Yes.
looks like a quadratic?
Because it has all the basics A, B, and C in the
Halala girl. Halala girl. Because it all has the what? The A, B, and C. What do we know about the A, B, and C? I know a quadratic is ax squared plus bx plus what?
and
Plus
C.
C. Do you see that? And then I come to whoever said, hey, it doesn't look like a quadratic, but we can use K substitution.
Yes.
Who's that?
Me, ma'am.
Why are you saying K substitution?
Because normally I hate using exponents if I can't solve them. So for
Well
me,
done.
if I use K method, I simplify this and find the value of K, then later on substitute. Then I've used lane. Simple.
Well done. So at times it might not look like a quadratic. For the person who said quadratic, normally with quadratic, you have something to the power. In this case, look at this. Our x. Okay, let's start with K substitution. She says that I look at it and see something similar and let it equals to K. Then I use K substitution. K substitution is normally used when you can see, man, or here I cannot easily simplify by just looking at it. So what are you going to choose K here to be?
E to the
E to the
exponent
power
x.
of x.
The same person who says, why don't we do e to the power of x as y is the same as K substitution. We're just changing a variable. So if we say e to the power of x, let it, because you write let K equals to e to the power of x. Then if we rewrite this, we say e to the power of x to the power minus e to the power of x minus 6. Do you see that? Equals to 0. Then you put K where you see e to the power of x. Do you see now it's a quadratic equation?
Then we factor the quadratic.
Yes, we factor with quadratic.
It's going to be k minus 3 and k plus 2.
Yes, we do that. Does it make sense for K substitution?
Yes, ma'am.
Now, whoever said it's quadratic, guys, let's do this. I have e to the power of 2x minus e to the power of x minus 6. No, before I go there. Someone said we isolate. Let's talk about isolation. Then we do what?
Take out the common factor.
And then take the common factor outside.
Which is gonna be e to the power x.
E to the
Then
power.
we left with?
We left
Minus.
with e.
Then we do what?
And then we
Divide.
we factorize it. No, sorry. We say e to the power x is equal to hi man.
Yes, continue.
Continue.
You're right.
Now, you know why I came with the isolation? It's because I know you guys want to do that. And in the exam, I'll put that as one of the solutions. Because I know some of you will do that. Remember, let me plug you here. Remember, the only time you can do this and say e is equals to, if this is 0.
Yeah, that's what I noticed.
Do you see that? Therefore, you can say e to the power of x is equals to 0 or e to the power of x minus 1 is equals to 0. Meaning isolation is not going to work for you.
Yeah, it's not.
Even if you took lane from here, because someone said lane. Even if you took lane from here and say e to the power of x minus e to the power of x, do you understand that there's no rule whatsoever in mathematics can help you to solve this lane function? Am I lying?
No.
No.
So meaning that isolation is not going to work. Only quadratic that's going to work. So I'm just answering everything you've been thinking. So in the exam, I put answers, even the things that you think, so that we all get right answers when there's only one right answer. So let's look at this. In quadratic, if I have k squared minus, let's make it x squared minus x minus 6 equals to 0. What do I do normally when I factorize? Isn't that I open two brackets?
Yes, you do.
Now, for the person who saw that this is a quadratic, you also open two brackets like this, isn't it?
Yes, ma'am.
Then I put what here?
The factors.
Which is x and I put
3.
x here. Do you see that?
And our factors is 3 and 2.
Okay, before we go to our factors, isn't that here I put x? When I factorize, I say x and x.
Mm-hmm.
Yes,
Even
ma'am.
here, you say e to the power of x, e to the power of x.
Oh, okay.
Do you see that? Then I go and put my factors, which is what?
3 and 2.
Minus 2 and 2.
Minus 3 and 2
Minus 3
And positive 2.
and
plus
positive
2.
3. You do the same here, minus 3 and positive 2.
Okay.
Do you see that? So you can
Yes.
go use substitution or by just looking, because someone was like, no, this is a quadratic. And this is how I act with quadratic. Now, because it's equals to 0 here, it's equals to 0, then we can say e to the power of x minus 3 is equals to 0, or e to the power of x plus 2 is equals to 0. Same applies here. We say x is minus 3 is equals to 0, or we just do what we do for quadratic, guys. And then we
So,
say x is equals to 3, or x is equals to minus 2.
so we shouldn't panic when we see e to the power 2x. We
Yeah,
can
we
just do
shouldn't
the same.
panic.
We can
Don't
just
overthink things.
I
Okay, so
overthink this. We really
okay,
overthink.
okay, can I do this? I just want something. My brain is telling me, there's something that you need to highlight here, which is very important. Remember the K person. Let's put your K. Do you see that? Isn't that here we're doing K substitution now?
Yes.
Mm-hmm.
Right? Okay, so with this one, I can say e to the power of x is equals to 3, or e to the power of x is equals to minus 2. Right? Are we all together?
Yes.
Now,
Yes.
let's do the left-hand side. Is there a number? Is there a
Mm-hmm.
number that if I put in e here, like in x here, it will give me a negative number?
Never.
Never.
Never. So this is not an answer. So we go on top
Okay.
of that. Yes. Do you see that?
Yes,
Yes.
ma'am.
Yes, ma'am.
So meaning that the only answer is this one. But we
Mm-hmm.
are looking for x. So what do we do now?
That's why the log
The,
Thank you. But which
Use
log?
the
The
natural
in
law,
the
the
e
natural
the
law.
lean the lean
And then
yeah.
why do we use the
The
natural
lean.
log?
I don't know because we see this e that is here,
Because
but
there's
again, I
E.
don't.
And because of which property?
Uh,
inverse.
Thank you. The
or the
inverse property.
inverse property.
So because of the inverse property, we then use, we know that the inverse of e is what? Is
ln.
ln. So then we say ln e to the power of x, which is equals to ln of 3. So then we know that x will go outside. So x ln of e, according to the ln properties, the natural logarithmic properties, we know this is 1. So x is equals to ln of 3. Are we together there? So we have solved a question in the exam and solved the question in the assignment.
Mm-hmm.
All right. Now let's go to the case substitution person. By having this, you're not done, isn't it?
Yes,
Yes.
ma'am.
Right?
Yes, ma'am.
So
Mm-hmm.
what you do is remember you said let k is equals to e
E.
to the power of x.
X.
Mm-hmm.
So you say therefore it equals to k is equals to this, k is equals to that. Once you get there, you then say, okay, I know that my k is equals to e to the power of x. So you say k is equals to e to the power of x. Then you put back, you put e to the power of x here, which is equals to 3, or e to the power of x here, which is equals to negative 2. Now, we know that whatsoever you can choose a number in the number line from negative to positive infinity, you will never find a value of x to put here such that it gives you negative number. So this is not equals to. So meaning you're remaining with this. So this is e to the power of x equals to 3 because of the inverse property of a natural logarithmic function. We know that the inverse of this is ln, so just put ln inside there is equals to ln of 3. So this means that this is what? This is x is equals to ln of 3.
Yes.
And remember, if your answer was like this ln of x is equals to 3, it means we're going to say e to the power of ln of x, e to the power of 3. So x is equals to e to the power of 3. I'm just showing this. You may never know it will appear. Are we all together?
Yeah.
Alrighty. So can I move on?
Yeah.
Dango. So meaning that we have solved a question in the exam or a question in the assignment. Yeah. But the equation this has no solution because every time you put any value of x in there, it will be greater than 0 for all values of x. So therefore, ln x is equals to ln of 3 is the only answer. Logarithmic equation. A logarithmic equation is one in which a logarithm of the variable occurs. Some logarithmic equation can be solved by using the fact that a logarithmic is a one-to-one. And you should see they're saying some equation, meaning that there are equations that you can't use the one-to-one property for specific reasons for now that we will not use now, but later on. Now they're saying that can be solved by using the fact that logarithmic functions are one-to-one, which means back to inverse, inverse back to inverse property, right? So this means that this implies that. The following guideline describes the process of solving a logarithmic equation. Guidelines for solving a logarithmic equation. Isolate the logarithmic term on one side of the equation. You might first need to combine the logarithmic terms. Assignment question 1. Combine. We did combination last week. So don't tell me you don't know what combination is. Now write the equation in exponential form. We did that one last week. And raise the base to each side of the equation. Now solve the variable. Let's solve. A. What is the answer to A?
I'm testing when there's no base, when they say we should put 10.
Wait, let's start with the person who's asking a question. When they say?
I'm not sure if it implies to lim and log. I mean, it also implies in lim as well. That if there's no base, you need to put a 10 as a base. Is it also applies everywhere, or what is going on with that?
No. Someone answer that.
No, lin just means the base of it is e.
Of an e, that's it. It doesn't have the same rules as log.
No, the difference between a log and the lin is just that the in log base is 10, the common base is 10, and then the in lin is.
Well done.
Okay.
So lin has a base, but the base is what? Is e. Now, because e is special in calculus, so then they decided, whoever was deciding, will say, no, let's not call it ln x base e. Let's not call it log x base e, but we'll call it ln x instead.
Okay.
Are we all together in this department?
Yes.
Yes, ma'am.
So let's solve A, and I gave you the answer in the above equation. I told you use it somewhere. Let's use it.
It's e to the power.
Danko, e to the power of ln of x is equals to e. Yeah, sorry. It's equals to ln to the power of 8, guys. Now this is just equals to x. Why? Because we know that e to the power of log ln is e that. This is our property. We know that if the base is the same as this, then we're left with x. So x is equals to e to the power of 8. Yo, guys, I gave you the answer. Yeah, nice. Alrighty. That's how we solve it. How do we solve the next one? And I'm going to zipper someone because someone said we throw away the logs last week.
No, not in this case.
Ooh, in this country, in this world, we throw away the laws.
Okay, I'm not sure
Don't,
if you can tell
guys, don't
this
say in
one.
South Africa because we have what's this? We have UNISA is
International.
all over. Yes, UNISA is international. Do you see that?
Yes, ma'am.
Yes. So I know someone. I know exactly someone. Last time I spoke to someone from Mozambique here. Okay, so
I think for B, we gonna take the we're gonna take 3 and move it and make it as log 2 to the exponent 3, and then take the 25 minus x out on the right hand side.
Ma'am,
you said something, but I don't think is what I want the way you say it.
ma'am, can't we say
Maybe I'm using the wrong method for the wrong equation. I don't know.
Let's hear. What do
yes? Ma'am, can't we say 2 to the power of 3 is equals to 25 minus x?
the power of 3?
2 to the power of 3 is equals to 25 minus x. Using one of the methods that ma'am showed us when ma'am introduced the logs.
But you don't say 2 to the power of 3. That's the thing. You don't say 2 to the power of 3. What do you say?
Oh, you say log 3 to the power 2, and then you take the 25 minus x to the right hand side.
I know, but you guys are converting
Ma'am, I
the
think
log
we
into the exponential form. It's fine. It's fine. But I don't want that.
Which one you want?
I want you to use the inverse property. The inverse property. Okay. I see you guys. You guys want to drive me somewhere here.
No,
I don't want you. I want you to use the inverse property. What do you notice first? How are you going to use the inverse property?
When you use the inverse property, aren't we supposed to solve first before we use it?
Oh. What is the inverse of log with base 2?
It's the exponent.
Which is what?
Exponential
2 to the power of
function.
x, isn't it?
Yes.
So meaning that because of the inverse property, I can say 2 to the power of log. Both sides.
Divide by log.
Do you see that? And these two, according to our log laws, if I have a 2 and a 2 here, I only remain with this. So this becomes 2. 25 minus x is equals to 2 to the power of 3. Do you see that?
Yes.
The reason why, because I know what you guys did. You said, isn't that we said when we are converting, we take this to the power of that, then it's equals to this. I do understand, but me, I want to use the inverse property because I know this might deter you somewhere. That's why I'm using that. That's why I'm saying this. This was last week. This was saying that you say 2 to the power of that, then is equals to this. That was last week's work. So we want to put more tools in our mathematics bag. Do you see that?
Yes.
Because of the inverse property function, this can apply. So meaning that, you know that if you wrote like this, you can also write it like this. Oh, sorry. What am I doing? You know A equals to B is the same as B equals to A, ne? I'm just putting it out there. It's a tool. You need to put it in your maths bag. I'm just writing it out there. Alrighty. So now let's solve for x. Then we have that minus x is equals to 2 to the power of 8. That's 8 minus 25. So that is x is equals to 25 minus 8. So x is equals to what?
17.
17. So therefore, I did not say what you said here, this to the power of this is equals to that is wrong. I was just telling you that I wanted you to use the log, the one-to-one relationship, because they spoke about one-to-one relationship. So let's go. I hope I don't lose anyone. Yes. Do you see that? This is what they wanted you to raise. There we go. Raise 2 to each side. That's what they wanted to do. That's how you get the exponential form. What you have been saying, this to the power of that, get this. I'm glad you are using your tools. Okay, we're not using calculators. Also, here they're checking the answers and we see that our answer is right. All righty.
So, Mama,
Yes.
if we use the one for last week, what's gonna happen? It's gonna make our answer wrong, or what is gonna?
It's not, because your question says log of 25 minus x is equals to 3. Last week we said that we changed this to an exponential form. How do we change it? We say 2 to the power of 3. So we say 2 to the power of 3 will be equals to this part. Do you see that we end up with the same thing?
Oh, I think that one is the one that I understand more.
Yes. So you can do that, but you need to remember the inverse property. That's what I'm telling you how you got here. So the inverse property tells you how you got here, basically.
Oh, okay.
I saw Lydia said, "Can you please open the class?" They got kicked out. Okay, let's just finish here because I'm being distracted a little bit here. Okay, let me just open the class and close it. Do we need 5 minutes break?
Yes.
Okay. So I'm unlocking it, then I go and drink water and then I come back. And then remind me to lock it. Sharp, sharp. Please someone type in the chat that it's unlocked.
Yeah.
Ngwenya Rena. Coming back now. I come back. Can you hear me?
Yes.
Okay, now I'm locking the
Yes.
class then. So that the beepings don't do whatever. I hope people have joined it. Where's me, I get distracted very easily. I know even in school, I was that child. Don't ask me how I passed. I never had anything in class, but I was in class. See? Which benefited me. Yes, I've never had anything in class, but I was in class and I'll think somewhere else. And then when I start, I'm like, oh, this is what the teacher was talking about. And then I'm like, oh, okay. You see? Just like that. So I think my mind was absorbing, was doing osmosis. So let's look at a logarithmic equation. Now they say logarithmic equation are used to determine the amount of light that reaches various depths in the lake. This information helps biologists to determine the type of life a lake can support. Did you hear that, guys? So whoever is going to be a biologist, they'll be using logarithmic function. As light passes through water or other transparent material such as a glass or a plastic, some of the light is absorbed. It is easy to see that the water the more the maker the water, the more the light is observed. The exact relationship between light absorption and the distance light travels in a material describes the next example. So let's look at the next example and discuss. And discuss the answer. Hello, can you hear me? Next example and discuss the answer, please. Guys, you are keeping quiet. It means that the answer is right. Then it means you're okay. Then I can move to the next example.
I'm still observing.
Oh,
No,
please
ma'am, we're
observe.
still
Please observe.
analyzing.
Sorry.
Yeah. Yeah.
Definitely clueless.
I am lost in.
I'm lost, babe.
No, ma'am. Ma'am, can you do this for us?
Anyone who knows this Lambert's law, whatever.
I don't even know it.
Yeah. Well, if we don't know it, then yeah, this is messed up. So there's nothing we can do.
You say, I don't know the law, but when we read there, they say if IO and I denote the intensity of light before and after going through a material, and X is the distance in feet. So where is
Yeah, but
K a constant?
yeah, what's the value of that K? See,
So, guys, must we make A the subject of the formula? Just like say.
No, K,
make what
K
the sub-
is a constant. So there's a value for K. I don't know the value for K, but we also don't have the type of material.
The
But
problem. The
we can use
problem.
the value.
This is yeah. Lambert law is a physical science. Don't. And I
But
don't
now,
know. Ukuthi ingenaphi ke lana. I'm very confused. Whether we're supposed to apply both of them.
what are we even solving for?
That's what I'm asking myself as well.
Because if it's like this, all we can do is, oh, there we go. Solve for I. Okay. Ma'am, please show us the values again.
Okay, we have K, we have I. Oh, that means you're gonna substitute these ones that we have that we are given. and then solve for I. Okay.
What are we substituting instead?
We do have
But that's the second question. It's more like a follow-up question. The first question says we should solve for I. So why are we substituting the values given in the second question to answer the first question?
I think maybe the first part we should just isolate I.
Is that I think that's that we do as well.
Then after isolating I, we use that I to solve for B.
Is
Let's do that.
Well
now.
done. So how do you solve for I?
Divide by -1/k, both sides.
Okay. Divide by -1/k, both sides. So then we left with
And then
-1/k.
equals
what is
x minus x
what?
times k.
Then
And then what do you call that? The e thing, I think.
so what do I do with the E thing?
Like put it both sides. The English is not English.
How do you put it?
What
I'm
about the
I'm
negative?
putting it in here, both sides. I'm putting it. Is that how you want me to put it?
No.
What about the negatives? It has been
you
left
use
out.
What
the
about the
natural log
negative, ma'am? I
to
thought
write
we
things
Thank
neglected
you.
in
the
the
negative.
exponential form.
Thank you. Thank you for the negative. I put it. Use the property inverse function. So meaning that we know that if e is to the power of ln of x, this is equals to x. If this is ln of e to the power of x, this is equals to x. And the reason why I'm emphasizing this because one of your assignment question, which is the last question, deals about e. Let's do that. Hi. I'm not giving away answers, guys. Yo. sorry. So this will say if, because want this ln to cancel each other. Remember, ln is the same as log base what? So this is over I 0 equals to e to the power of negative xk. So then we know that this and this, they don't cancel. They just use the inverse property law. So then this is I over I0 equals to e to the power of negative xk. This implies that I is equals to I0 e to the power of negative xk. So such questions, you should expect them in the exam. Are we all together there? Who did we lose, guys? Did I lose anyone?
No, ma'am. Can you please re-explain it?
Yes, please.
All right. Where is it? Is here. It is here. Isn't that they will say it's so for I, meaning they say makes I the subject of the formula. That's another English they can use. Right? So meaning that we divide by k, we are all okay here, right? Because we want to remove this part. Once we remove that part, we remain with ln. We want to remove ln. We don't throw it away. We introduce e to the power of this whole thing here. E to the power of that whole thing, because then it gives us the property that e to the power of log of ex is equals to x because of the log law, this log law that says if I have e here and e here, then the answer is just x, which is the same as log of x base a, which is x, because here and here I get x. So that's the inverse properties of function. Now we then simplify, because here inside we're left with this inside here. So it's this one. And that is that part. So then we just multiply and simplify it like that.
Ma'am,
Mm.
You said putting E both sides is doing what? Using the
When you
inverse
say, so when
property.
you're putting, eh?
Using the inverse property.
Yes, it's the inverse property when you're saying putting E. It's
Okay.
this one here. It's like this. Isn't that we're saying I have ln of x is equals to 8, isn't it?
Mm.
And according to the inverse property, if I take the function, put the inverse, please mute, I get x. Or if I take the inverse and put the function inside, I get what? I get x. Please mute. So I know that my y is equals to e to the power of x. If my function is y equals to e, then the inverse will be what? Then the inverse will be log of y is equals to log of e base x. I mean x base e. Do you see that?
Yes,
You
ma'am.
remember that, right? Now, because this is the inverse of that, and this is the inverse of that, then this property applies. This is your assignment 2 and assignment 3, if I'm not mistaken. I didn't check it. Therefore, it means that if I go and put e where I see x and put log of that, log of e to the power of x, because of the log property, do you see that? This becomes x. Same applies if I do log of x. This property here also applies, which is x. That's what we have been using. Because the function is a one-to-one function. Can I move on with live and slides? So then here, now that we got that our I is equals to, is it what? Wait, where is it, guys? Where is it? It's here. Is what? I0 e to the power of negative xk. So I0 e to the power of negative xk. Do you see that? Then we
Yes,
can go and
ma'am.
say, okay, k is 0, comma that. I0 is 14 e to the power of negative
20.
k, which is what? 0,025. K is 20. Then they find I. So the important part was, were you able to do that? So let's see. We are on the right track. Then the B is the 1. And that's how you do it. Not in the calculators. Did I miss anyone there? Yeah, this section is a bit longer. Hello, did I miss anyone?
So, ma'am, do we leave it as 14e to the minus, not with the answer?
Not with the answer. Remember what's important,
Okay.
guys, in maths. What's important is not the answer. It's so because with us our exam is multiple choice, right? I'll leave it like this. And if I give you an answer, it means it was simple to multiply, basically. Do you see that? It was simple to do the maths. But the important is, are you understanding your work? Do you know how to apply it, when to apply it, and why we're applying it? Because some people will just do. And in maths, if you just do, then there will be a problem. Compound interest, guys. They say if a principal P is invested at an interest rate of R for a period of T years, then the amount A of the investment is given by this: simple interest, compound interest, and compounded continuously. That E in compounded continuously. They say we can use logarithmic to determine the time it takes for the principal to increase to a given amount. Do you remember this? You did this in grade 12, where you didn't know why you are introducing the log, but you want to solve for T and introduce the log. Now you know, because of the one-to-one relationship. Now they say that a sum of 5,000 is invested at an interest rate of what am I saying? Interest rate of 5% per year. Find the time required for the money to double if the interest is compounded according to the following. method. How are we going to do that? We must do data, guys. It must be done. How are we going to do that? And I don't want you to use a calculator. I do not want you to use a calculator, so let's work. Should I let you discuss? I enjoy seeing how you guys are able to think, which is very important. Hello? I'm here. Say something, guys.
Hello.
Ma'am, our A is going to be double the 5,000. It's going to be 10,000. Then our P is going to be 5,000.
So our A is going to be 10,000. So you're not going to use a calculator, ne? A is going to be 10,000. Then our P is going to be 5,000. Then what?
And then our N is going to be 1.
So they say N is going to be 1.
Yes. But then I think we're going to multiply it with 2, ma'am, for A.
Okay. So for A, our N is what? You are saying it's 2.
Yes.
All right. Then I do what?
And then the I is unknown. That's what we're looking for.
It's 5%.
So I is equals to 5%.
0.
Thank you.
0.0.
Sorry, yeah.
All right. Then what do I do?
Substitute into the equation.
Which equation? Formula. Remember, you're not giving a formula sheet. Which formula? For A.
Is equal A
equals to
the
P
compound interest.
Open
I don't know it.
1
1 plus I
over N close bracket N. There it is.
N.
NT.
NT.
Is it necessary to convert the I?
Yes.
It's necessary.
Yes.
Because in everything it's necessary. I'm just letting you know now. So if they say that so for example, can you go ahead and tell your grandmother that the electricity has increased by 5%?
No.
Or their grant has increased by 5%? Do you think she'll understand?
No.
You have to give a number. So it's necessary to convert it into a 0.05 when you're going to substitute it into the equation, always.
Okay, remember then what if now it's given as let's say 13.5 and so on and so on.
So you'll be dividing by 100. Remember, percentage means divisible by 100. Divide by 100. So this will be 0.135. Percentage means divisible by 100. It's a portion. Yes. If I give you the whole 100% and I decide I'll give you 5% of my heart, you don't know where the rest of 95 goes. So now, what do we do? What are we looking for? Before that, let's go and check if the formula is right, guys. There we go. They use R instead of I, guys. In our textbook, we use R. 609. Alrighty. That's what we have. So let's go back to our work. Let's see. Here we are. Let's substitute. We're not using calculators. We're looking for T. So you are solving as if you are solving in the examination. So I know my A is that. So this is 10,000. I know my P is 5,000. 1 plus 0.05 over
2
to the power of
2T.
2T. Yeah, I'm listening to you.
Amen.
Yes. So then what do we do?
Divide by
We're gonna
5,000.
divide by 5,000.
Thank you. Divide by 5,000. They do not cancel. They form a 1. This divide by this is 1. They do not cancel. I know our teachers used to say, hey, cancel. No, they form a 1. So 10,000 divided by 5,000, guys. Don't tell me you don't know. You know money. Obviously, you get this answer. 10,000 divided by 5,000.
2.
2.
Thank you. So this is 2 equals to 1 plus 0, 0. What is 0,05 divided by 2?
It's going to be 0,025.
If someone answered it like that, it means that in the exam I'll do that.
Oh my gosh, ma'am. Oh.
I'm just showing you that we are solving without using calculators here, guys.
What if the person who
Ma'am,
answered used the
what if you
calculator,
put
ma'am?
big numbers there? What if you put big numbers there?
No, I won't pick big numbers such that you don't know how to simplify them, guys. Yeah, man. I won't put big numbers.
I did not use a calculator.
Yes. So here we're not using a calculator. So this is 2 equals. What is 1 plus 0,025?
1,025.
To the power of t. Makunje says Anjan, guys.
We invite the log.
Produce the log.
Thank you. We introduced the log. Then what?
Bring down the 2t.
Thank you. Remember, this is the same. A equals to B is the same as B equals to A. So I can take this to the other side and write log of 1,025 2t is equals to log of. I've seen my students saying 2 is equals to x. Our grade 12 learners. And I say, no, don't write it like that. X is equals to 2. So do that as well because you're looking for 2t. So 2t is equals to log of 1,25 equals to log. Then I do what?
Divide.
By what?
2t.
Okay, then I divide by what?
Log of
You divide by log of 1,025.
Listen to my students. They say divide by log of 1,025 over log of 1,025. Then you're left with what?
2t.
And then we'll go and divide again.
Log of 2. Log 1,025.
And then what do you do?
You divide by 2.
We divide by 2.
So why didn't you do divide by log 2? Guys, you like a lot of work, eh?
Yeah.
Oh.
You want to divide. You're going to divide it by log 2. 2 log, what do I'm following what you are saying. Divide by 2, divide by 2.
Then I said so. Then I saw that you didn't take into consideration.
But you see, majority counts. Even if they say that the sky is blue, if 20 million people say the sky is blue, even the one who knows that the sky is not blue, they will be confused. So this is equals to log of 2 over
2 log of 1.025.
Is it 2 log of 1,25?
Yes.
Sure.
Serious, yes, ma'am.
I'm gonna put the divided by 2 on the next to the fraction.
If we divide with 2, it's gonna be 2 on the. Oh, okay.
Let me see. So if I have A over C over D, then this is A divided by C over D. Do you see that? So then this is A times D over C.
Yes.
So this is A D over C. So you're telling me the 2 is here. Are you saying that?
No, ma'am. On the right hand side.
Yeah, still.
No.
Shani, guys.
Where the line of the division is, ma'am, then you put the next to the line. Then you put the division and say C2.
Here. Times 2.
Yes. Divided by 2.
Yeah.
I'm
Oh,
asking, is it okay?
You want me to say divided by 2?
Yes, that's what I'm asking. Is it okay if I leave it that way?
You
Yeah.
have done math. So divide by 2, simplify. So this is equals to divide by 2. Divide by 2 is the same as what? Multiply by 1 over 2. Then this times this time that. So this is what? This is what we have
Okay.
been
Now
saying.
it makes
2 times log.
sense now.
Yes.
Yeah.
So
Even
this
the
is the
basics
answer.
are.
When you have used a calculator, you have something else. This is the answer. Let's check. Whether you are using calculators. And you use the calculator, I'm sure you have 0.07. You have 15.5. This is the answer. You have 15.75. Tell me if there's a 15.75. Tell me if there's a 15.75 here. If you got 15, this is how. So this is how we solve it in maths in our exam.
Now we understand, man. We've been arguing about this thing the whole week.
You see, so in the exam, this is how I'm going to give you the answers. Imagine now you have all of 5 answers are log something, and when you have a 15 comma something, which one are you going to choose? So make sure that you know. So this is how you're not going to use calculator. How do I do this one? Let's see. How do I do this one?
We use the continuous compounded equation.
Yeah, that's fine. So then 80, I know it's 10,000. I know it's 5,000. E, what is R? 5T
0.05.
divide by 5,000, divide by 5,000. Then this is 2E 0.05T. And then someone will say, I don't know the answer. Here, what do I do when I'm here? Then, well done. So this will be 0.05T is equals to ln of 2, 0.05, 0.05. Then T is equals to ln of 2 over 0.05. I hope I'm right with so much confidence. Yeah, so because they say compounded continuously, then it means we use the interest compounded continuously. So let's see if I was right, because I had so much confidence in myself, and I hope I'm not disappointed. Yeah, yes. Danke. Kancane. Siyavela. We're going to be inside phakathi in this math. So that's how then you solve for T. Now you understand why you were using logs in grade 12, isn't it? Danko. That's what matters. And that was the last section. Danko. First session. I know it was long, guys. Guys, it was so long. Any question from this section? If not, I move forward and I move on. Then I can stop the recording. If the question is not related, wait a minute. If the question is not related to this particular work, we stop the recording first. Then we can discuss.
Ma'am?
Yes.
Can ma'am go back to the first slide?
First slide, first.
Yes.
All right. This one. Where there's a Chinese, there's McDonald's. I'm thinking, this McDonald's, are they using dogs, cats, or what? The meat.
The next one, the next slide.
Oh, the next one. This one.
The next. Next. Yes, this one. What is X? What does X represent? Is it the X-intercept of that graph or just the X? And is the answer?
So the X just represent the X values of the domain.
Oh.
Where you're going to take and substitute to get Y.
Okay.
Yes. Yeah, bro. Any other question? Then we move forward, we go. Up we rise. No question for this section, therefore I shall stop the recording and stop sharing. Let me see if I have not put something very important or the solution to assignment 4 in the background.
Ma'am, can I ask a question?
Regarding this work?
Yes, ma'am.
Alrighty. Yes.
I just wanted to ask that one, the first example we did, ne?
Which one? I
that
don't
you said
remember
we
it.
cannot, the first, the
Which
one
one?
in, yes, ma'am. But ma'am, here I tried to use lean, ne? Like, yeah, but I got the same answer.
So basically, I think what I've noticed is even if you use lin, you might get the same answer because then for an exponential function, it divides itself. I noticed that here as well. Let me show you something. I noticed while we were doing it, I need space. So if we have x to the power of plus 2 is equals to 2 to the power of 4. Remember we said this is 4. So this is 2 to the power of 2, right? So if I introduce ln as well, 2x plus 2 is equals to ln of 2 to the power of 2. So then this will be x plus 2 ln of 2, which is equals to 2 ln of 2 over ln of 2 over ln of 2. So then this ln, this cancels. So then x plus 2 is equals to 2. Then x is equals to 2 minus 2, where x is equals to 0. Now, I noticed that as well, especially if you're going to solve for example 1. But now with example 1, it doesn't necessarily model a specific scenario. Does it make sense? So for example, it doesn't label, it model a specific scenario. Now in this case, if you're going to model populations, for example, population, they extremely increase. And the only function that uses an extreme increase of population, even during COVID, when you're going to model a problem that has an extreme increase, you'll say they're increasing exponentially. Do you see that? So we might not know for a simple equation like this, we notice that even if I use log, even if I use ln, but then the natural log is a specific case. In most cases for such question like that, they use a common log, that's why they're saying it's a common log. Maybe we might go further and ask why instead of using a common log, why instead of using ln, you use a common log. We can go and further check that, just for our own understanding. But in most cases, I've noticed that even in grade 12, they'll use log. Even in lower grades, not lower grades, but in other, they'll use the common log to solve for exponents. So if you see an exponent, you solve what? The common log. But the answer goes back to me answering as well. The reason why we do not use ln for this one is because we went back to the inverse property. We know that the inverse of an exponential is a log function. Do you see that? So it is more appropriate to use the log function than to use the e, because we only know that the inverse of e is what? Is ln. So that's why we didn't use ln. Instead, we use log, for as much as you might have gotten the same answer. But we need to continue say, every time you see an exponential, use log. That's more appropriate. Do you see that?
Yes, ma'am.
Yeah. So let me make an example. If I take water from the tap and water from my water that I finished bathing, and I cook pap, at the end of the day, both of them will be papa, isn't it?
Yes, ma'am.
But which one was not correctly used is the water from the bath tap. Do you see that? So it might say, but then because of the one-to-one relationship, where you know that the exponential function with a base which is not e, you should use log. So rather stick to log, because then you can justify your answer why you use log instead of ln.
Okay, ma'am.
Alrighty. Any more questions? Yes or no? Should I leave? Not leave, but should I leave the section and open the class? Silence means concern, so therefore I stop the recording.